Here we have a system as shown in this figure, and we need to find acceleration of these three objects. So the first step is very simple. We should draw all forces acting on each object. Basically, we call it free body diagram. So the first one, here we have 3mg, and upward we have a tension. For the middle one, 2mg, its mass equal to 2m. Upward we have a tension, and this tension actually equal to 2t. Let me explain it. Here we have a t, so here basically we have a t and tension also here. So here it should be 2t. Why? Because this movable pulley is massless, no mass. So according to the Newton's second law, total force acting on this movable pulley should be equal to ma, mass equal to 0, 0 times any acceleration equal to 0. So total force should be equal to 0. From here we can understand that tension here, force here should be equal to t plus t, 2t. Let's come to the last one. Mg, and upward we have a same tension because same rope. Rope is massless, so everywhere we have a same force, same tension. The challenging part of this problem, we don't know exactly in what direction objects will move. And it's very difficult to guess, and my advice, you don't need to guess. We will just assume all these three objects will be moving downward, and at the end, if one of them moves in opposite direction upward, we should get negative acceleration. From there we will understand which one will be moving upward. So let me say that first one will move downward with acceleration a1, the middle one moves downward with acceleration a2, and the last one moves downward with acceleration a3. I am assuming that they all will move with different accelerations. So now let's write physical equations in terms of mass, Newton's second law. Let me apply for all these three objects. So net force, resultant force acting on the first object equal to 3mg minus tension equal to 3m, its own mass, times acceleration. I'm assuming that it will move downward. That's why 3mg is greater than tension. Second equation for the second object, again Newton's second law, similar. Its weight, gravitational force, let's say 2mg minus 2t equal to its own mass, 2m, times acceleration. Same for the last one, mg minus tension equal to its own mass times acceleration, 3. So here we have three equations. We can simplify second one. We can cancel, we can lose, we can divide both sides by 2 for second equation. So, and we will have mg minus tension equal to ma2. Yes? So let's number these equations. This one is first equation, second equation, and the third one. So let's continue. Here we have three equations, and now let's highlight how many unknowns we have in these three equations. First of all, A1, A2, A3, and tension. So basically 4 unknowns, and we have 3 equations. It means we need one more extra additional equation in order to complete this problem. And this last equation, I believe it should be a relationship between accelerations, and this will come from the constant length of the string. Rope, string, the length of this rope is constant because it's not spring. it's not elastic, and we can use this idea. For this reason, let me draw this kind of figure. So this is for example, initial position of the rope string. The length of the rope string at the left side, let me denote as a L1, here L2, here L3, and at the right side, let it be L4. At the beginning, after some time, system begins to move and the position of the rope will be different. Let me assume the left side of the rope moves downward for distance x1. The movable pulley, which is here, moves downward for distance x2, and new position will be like this, yes, approximately. And this distance equal to, let me call it x2. And the right side end of the rope moves downward for distance x3. Now the initial length of the rope actually equal to L1 plus L2 plus L3 plus L4. And also this part we have some length, some rope, but I will not count it because it will never change. Or we can add it, for example, here L0, here same size L0. Totally we have 3 L0s on the pulley. Now, after some time, rope is moving, but we know that the length of the rope should be constant. Now let's write the new length of the rope by taking in account x1, x2, x3, which is the distance that objects move. So this will be new length of the rope, basically. Let me use different color. This is a new position of the rope. Starts from here. Now let's come to the left side. The length of the rope at the left side becomes longer, yes? L1 plus x1. Agree? It was L1 at the beginning. The upper part of the rope is not moving. The end moves downward for x1. Plus, at the middle, L2. L2 plus x2 here. Also plus L3 plus x2 plus L4 plus x3 plus still we have a 3 L0s, yes? So here from this last equation we can cancel all these initial lengths, 3 L0. Basically we have at the left side 0, at the right side x1 plus 2x2 plus x3. And we know that x1 is proportional to the a1. To be exact, x1 actually equal to 1 over 2 a1 t square. So due to this logic, we have 0 equal to a1 plus 2a2 plus a3, and this will be our equation number 4. Equation number 4. So now we need to just substitute all these 4 equations. Further is totally pure math. At this point, we finished physics part of this problem. Further is totally math, and we need to just solve. That's all. So from first equation, a1 equal to 3mg minus tension over 3m, or we can say g minus tension over 3m. From equation number 2, A2 equal to G minus T over M. From equation 3, A3 equal to same G minus tension over M. And I will substitute all these accelerations in equation number 4. Why? Because in this equation, in equation number 4, we will have only one unknown, which is tension. First of all, we will find tension, and we'll come back to the equation number 1, 2, 3 in order to find accelerations. So now let's continue. So 0 equal to A1 plus 2 times A2 plus A3. Let me substitute. 0 equal to A1 G minus T over 3M plus 2 times A2, which is 2G minus 2T over M, plus A3, which is G minus T over M. So from here, we have a 4G minus T over 3M minus 3T over M. Which means 3G minus, here we'll have 3M and 10T, yes, 3, 9, 10, yes, 10T equal to 0. From here, tension equal to 10T over 3M equal to 4G. From here, tension equal to 12 mg over 10, or we can say 6 over 5, yes, 6 over 5 mg. Now we know the tension. Now we can find A1. A1 actually equal to G minus T over 3M. So G minus 1 over 3M times tension, which is 6 over 5 mg. Mass 6 and 3, here we have a 2. So G minus 2G over 5, yes, 2G over 5, which means 3G over 5. As you see, acceleration is positive, 3 over 5G or 0.6 G. We said that A1 moves downward and the result gives us positive number. So first object moves downward. Now let's come to the second object's acceleration. A2 equal to G minus tension over M. Let's check. Yes. G minus 1 over M times tension, which is 6 over 5 mg. Mass. So G minus 6 over 5G. Answer is minus 1 over 5G or negative 0.2 G. This is a A2. And the A3 is also equal to A2 because A3 equal to same equation we have, and negative 0.2 G. So as you see, A2 and A3 is negative. It means both objects at the middle and the object at the right will move upward with acceleration 0.2 G.